Hello everyone, I am Sujata Moril. In this video, we are going to discuss topic of the transform initial value theorem and final value theorem. Initial value theorem. If z transform of f of n equal to f of z, then f naught equal to this value where f naught or f of 0 is the initial value of the sequence. Then f1 equal to this value, f2 equal to this. Now for this proof, we apply the definition of z transform. F of z equal to z transform of f of n. Here we apply the definition summation n equal to 0 to infinity f of n z to the power minus n. If we expand the terms by substituting n equal to 0, we get f naught, n equal to 1, we get f1 z to the power minus 1, and then n equal to 2, we get f2 z to the power minus 2 in this way. Now, if we taking limit z tends to infinity f of z, here all these term tends to 0. Here this value tends to 0, this value tends to 0, and all other higher next terms are 0. Therefore, we get f naught, that means a result. Now for second result, f1 result, we consider limit z tends to infinity, z into a capital F of z minus f naught. Limit z tends to infinity, z into, we expand the terms, capital F of z value is f naught, f1 z to the power minus 1, f2 z to the power minus 2, and so on. And here f naught value. F naught get cancelled here. Then f1 into z, f1 z to the power minus 1 into z, that means we get f1. And then f2 into z to the power minus 1, this term gets tends to 0. All other terms tends to 0, we get the value of f1. Similarly, we find out the value of f2. Now, we discuss problem on this. If f of z equal to this value function of z, then find f2. For this, we apply the formula. Consider f of z, limit z tends to infinity of this term. If we substitute directly, we get its value 0. We are taking z square common from the numerator and z to the power 4 from the denominator. Substitute the values, then we get its value equal to 0. Now we find out f1 by using the formula f naught, substitute the value 0, and here multiply by z, simplify the terms, then we get here 1 by z, that means again its value f1 value equal to 0. Therefore f2 equal to, by using the formula here, f naught is 0, f1 is 0, therefore we have to solve only this f of z square into f of z term. Therefore, we taking z square common from the numerator and z to the power 4 from denominator and cancel these terms, we get the value 2. In this way, we find out the value of f1, f0, f1, f2, and so on. Now, final value theorem. Here, z transform of f of n equal to capital F of z, then f of infinity, that means limit n tends to infinity, f of n equal to limit z tends to 1, z minus 1 f of z. For this proof, apply definition. Summation n equal to 0 to infinity f of n plus 1 f minus fn. Instead of fn here this term, therefore we write down z transform on this. Now expand by using shifting theorem, previous property. That means this property is discussed in the part 3 properties of Z transform video. Z transform of f of z minus f of 0 and Z transform of f of n is capital F of z. Now this f of z term and this f of z term we taking outside, therefore z minus 1 into z f of 0 gives the equation number 1. Taking limit as z tends to 1, then we write down this term as this way. Now expand the left hand side f of by substituting the values n equal to 0 to infinity, 0 to infinity and taking limit as n tends to infinity. Then right hand side is this way. Now here f of z, this f of z cancel with this, then f of 1, f of 2 and so on, we get the value only f of n plus 1. All terms get cancelled. Therefore, limit z tends to infinity, z minus of 1 f of z. Now, n plus 1 we can write down as fn because n tends to infinity. Therefore, this is the final value theorem. Thank you.